Hello and greetings to everyone. We are from Group 3 and today we would like to present our project titled E-Hailing Based Smart Transport Optimization System. In Malaysia, there is an abundance of e-hailing options to choose from, such as Grab, Maxim and so on, but it is very time consuming for users to compare their cost effectiveness. Therefore, our project will solve this issue by first proposing possible digital-based systems as design solutions for selecting cost-effective e-hailing. Second, conducting comparative analysis between them, and lastly, to map out the development timeline using project management methods. Our group came up with the first design of a web-based calculator that will help display comparison tables of e-hailing providers. Therefore, the decision is solely done by the user. Another design is a mobile app, which is far more convenient by automatically recommending the cheapest, fastest, or best value option to the user.
In this section, I will present the budget and financial assumption for the two proposed alternatives. Alternative A is a web-based comparison calculator. The total fixed investment cost is 5,482 ringgit, which include website development, cloud service, and planning activities. The monthly operating cost is 2,295 ringgit and 84 cents, resulting in a total one-year project cost of 33,032 ringgit and 8 cents. Next, Alternative B is a mobile recommendation application. This option requires a higher fixed investment of 32,482 ringgit due to system development costs. Its monthly operating cost is 4,441 ringgit and 67 cents, leading to a total one-year project cost of 85,782 ringgit and 4 cents. For the financial assumptions, Alternative A targets 500 users and generate revenue mainly through advertising from e-hailing service provider with an estimated annual revenue of 20,000 ringgit. Alternative B targets 5,000 users and charge a subscription fee of 12 ringgit per user per year. Both alternatives are evaluated using MARR of 8% and a study period of 10 years.
Let's look at the cost and revenue analysis. For Alternative A, the annual revenue is 20,000 while the annual operating cost is 18,550 ringgit and 8 cents. This results in a net annual benefits of 1,449 ringgit and 82 cents. For Alternative B, the annual revenue is 60,000 for subscription fee, while the annual operating cost is 44,300 ringgit and 4 cents. This gives a much higher net annual benefits of 15,699 ringgit 96 cents. In addition, the total development cost for both alternatives are 3,000 and 30,000 respectively. The economic life analysis was conducted to compare the two alternatives. Based on the evaluation, Alternative B achieved a higher present worth, higher annual worth, and a shorter payback period. This result indicate better economic performance, making Alternative B the preferred alternative. An incremental investment analysis was then performed to verify the decision. The result shows that both the incremental present worth and annual worth are positive, meaning the additional investment is economically justified. Therefore, Alternative B remains the recommended option as it provides greater overall value.
For section 4.0, I will focus on how project management methods are applied to implement the e-hailing based smart transport optimization system. First, in resource planning, the project identifies 4 main resources, including human, financial, software, and information resources. These resources are needed for data collection, fare comparison, system development, testing, and documentation. Next, the project used a work breakdown structure to break the whole project into smaller and clearer tasks. The main phase include initiation, planning and requirement analysis, followed by data collection, system design and development, system testing and evaluation, and finally project closure. This helps the team clearly understand the work scope, task sequence, and responsibilities. Besides the WBS, a risk breakdown structure is also used to classify project risk into technical, data and information, financial, operational, external and project management risks. This allows the team to identify possible problems earlier and prepare suitable control actions. After that, the project constraints are considered, including technical, physical, and resource constraints. Limited availability of skilled workers, budget, internet access, and testing device may affect the project process. Therefore, the project is classified as a resource-constrained scheduling problem, meaning the main limitation is resource availability, while the project duration may be adjusted if needed. Based on the project priority metrics, performance is the main constraint because the system must give reliable fare comparison and recommendations. Cost is enhanced by using low-cost tools, while time is accepted as flexible if extra testing is needed. Finally, the project duration is set to 1 year from 1st April 2026 to 1st April 2027. The timeline also helps the team to monitor task dependencies, ensuring that each phase is completed before the next two proceed smoothly, especially from data collection to system development, testing, and final project closure. Overall, by using resource planning, WBS, RBS, constraint analysis, and scheduling, the project can be implemented systematically and support the strategic goal of providing a cost-effective smart transportation solution.
I'm going to present about the implication of this project toward the e-hailing related organization, especially the e-hailing company and also our society. So from an economic perspective, e-hailing companies' revenue may increase due to the higher customer demand for e-hailing services. This is because customers may find e-hailing a more convenient options for traveling, as the comparison system allows them to choose the cheapest and most convenient e-hailing services. In addition, our project can improve the company's credibility and integrity, as the comparison system encourages the e-hailing company to improve their data privacy and fair transparency, so they can be more trusted by their customers compared to their competitors in our fair comparison system. Thirdly, the system can enhance companies' corporate social responsibility (CSR) effort by encouraging greater involvement in social initiatives. This is important because CSR can improve company brand recognition, which in turn to help companies to strengthen their competitiveness in our comparison platform. Now I'm going to present about the implication of this project toward the society. So this project provides economic benefits by offering affordable transportation, helping the member of society without the private vehicles to travel easily to their destinations. It also reduces car ownership costs, allowing savings to be used for investment or skill development to improve the quality of life. Ethically, this system increases transparency by enabling fair and service comparisons, helping users to make informed choices while promoting fairness and accountability in the e-hailing industry. As a result, the system helps protect consumer rights, promotes accountability among service providers, and contributes to a more trustworthy and ethical transportation marketplace for our society. Socially, it improves the accessibility and convenience by allowing users to compare e-hailing services on a single platform. This encourages more frequent use of e-hailing services, making daily travel to work, education, and healthcare easier and more efficient. In a nutshell, there are many benefits of this project toward the society and also the organization.